Hey Pre-Calculus, I've got a new video for you. It's 3.3. We're going to introduce function composition into this mix of things. I think you guys have seen function composition before, but there might be some ithiness on the notation of things, so stick with me, and hopefully you guys will be enlightened with new knowledge. So first of all, parentheses, f minus k, parentheses, x, parentheses closed. What does this mean? Well, it's not too complex, actually. This is just stating I'm taking the function f, subtracting the function k, and both of those functions are in terms of x. So this is f of x minus k of x. And what I'm doing is I'm giving you four separate functions to work with on this, on basically these operations of functions. So the first question is, how do we find a composite function f of x minus k of x? We literally only have to take this polynomial, 4x squared minus 4x plus 5, f of x, and then subtract our k value, 3x squared minus 3x plus 4. Is it really that easy? Well, for this problem it is. All we got to do now is polynomial subtraction. That negative gets distributed to all hold on. Sorry. That negative gets distributed to all parts of the second polynomial. So, this is going to be negative 3x squared. This is going to be negative 3x. So it becomes a positive. And this is going to be negative 4. Yeah, and then this just stays the same. So 4x squared minus 3x squared is 1x squared. Negative 4x plus 3x is negative 1x. 5 minus 4 is positive 1. This is the function f minus k of x. And its domain, because it asks for their domain as well, is, well, it's a polynomial. So polynomials have domains of negative infinity to infinity. It's all real numbers. And I didn't put interval notation, so technically I'd be okay to just say all reals. Let's try the next one. F dot k of x just means multiply the two. So the first one, we just subtracted the two polynomials. F of x times k of x. In this case, we have to actually multiply these monstrosities. So here's f of x times k of x. No me gusta. But it's really just like Math 1, Algebra 1 review. You're taking everything, 4x squared times everything in the second group. So I'm gonna work this out. 12x to the 4 power. Remember, you add the exponents when you multiply powers of the same base. Negative 12x to the third. And then it's going to be positive 16x squared. Okay. For the second calculation, taking everything times negative 4x, I'm going to actually stack the like terms as I see them. So negative 4 times 3x squared is negative 12x cubed. So I'm just going to put it right underneath my other x cubed term. Negative 4x times negative 3x is going to be positive 12x squared. And then negative 4x times 4 is going to be negative 16x. Does that make sense? I'm stacking the like terms as I see them because it'll be easier to organize my thoughts when I have to compute at the end. And then my last one, take 5 times everything in the second group. So you're going to get 15x squared minus 15x. Hopefully you guys can see that. Yeah, you can see it. And then 5 times 4 is positive 20. So overall, the new function, f of x times k of x, is 12x to the 4 minus 24. Remember, when you add or subtract powers, you do not change the exponents. It's still going to be x to the third. Let's see, 10 plus 10 plus 10 is 30. 7 plus 6, 43. 43x squared. All right, negative 16x minus 15x is negative 31x. And then make sure you put the plus 20 at the tail end. All right, so function subtraction, function multiplication. What's the domain? Well, it's still a polynomial. The domain is going to be all real numbers. Keep in mind that this would be the other way in which to express your domain, negative infinity to positive infinity. And we've got through our first 2 examples. Let's check out number 3. So for number 3, that's h slash k, which means basically h divided by k. So it's h of x divided by k of x. Now look at your note sheet. I'm not going to scroll up and down on this video. That's going to be maybe too exhausting. The h is root x. The k value is 3x squared minus 3x plus 4. So if you recall from the 3.1 lesson we did on domain, any even root means the thing inside of it needs to be set greater than or equal to 0. Okay? And in any fraction, you set the bottom not equal to 0. Those are spots where the function cannot live. So I'm looking at this thing and I'm asking myself, what factors of 12 add up to negative 3? And I'm not coming up with anything. So what we have to do is use the quadratic formula. Hopefully this is tattooed in your brain so that you can access it very easily from time to time. My b value is negative 3, so it's a negative 3 plus or minus negative 3 squared, which is 9, minus 4 times 3 times positive 4, all over 2 times 3. All right, this is an interesting thing. Inside the root, I get a negative number. It's going to be 9 minus 48. 9 minus 48 is negative 39. Which means there's no real solution here. No real solution. So if there's no real solution to the bottoming equals 0, that means the bottom can't ever equal 0. So because of this, the bottom cannot equal 0, at least with real values. Okay, so what that means is there's no domain issue with the denominator. There's no domain issue with the denominator. So it's kind of like if this root didn't exist, you'd say all real numbers. But because this root does exist, that's going to be our domain. So the domain is what you see right up there. They're getting a little trickier, yeah? Let's check out number 4. All right, this is altogether different. I'm actually, instead of h of x, which is root x, I'm saying take out the x and replace it with negative 3 minus x squared. So they're saying if you take out the x on the left and replace it with negative 3 minus x squared, on the right do the exact same thing. Take out the x and replace it with negative 3 minus x squared. So it's almost like I'm not operating on the function. I'm not adding, subtracting, multiplying, or dividing two functions. I'm basically saying, hey, your x is going to be replaced with an entire variable expression. So that's h of negative 3 minus x squared. Now, how do you determine the domain of that? Well, since it's inside an even root, you have to set it greater than or equal to 0. And this is tricky. Remember, if it was something more complicated, then you had to find critical numbers. So I'm going to do the critical number thing over here. So the critical numbers is when I set this equal to 0. And if I add x squared to both sides, I get negative 3 is equal to x squared. But, you know, I'm noticing right off the bat that I can't even square root both sides because there's a negative number inside the square root. There's no real answer to this. So I got to take a different perspective. Before it was all reals when you said no real solution. It's not like I'm trying to determine where the bottom can be 0. I'm just trying to figure out what the critical numbers are. It doesn't seem like there's any critical numbers. So here's what I can do. If there's no critical numbers, then you're literally just testing negative infinity to infinity. Right? Because what did we do? We find critical numbers. We use those to establish intervals. There's no critical numbers. So here are my intervals. Test a point. 0. If I plug 0 in right there, is it greater than or equal to 0? Well, negative 3 minus 0 squared, that's negative 3. That is not greater than or equal to 0. Wow. So, what's the domain? There is no domain. This function does not have any discernible points, at least in the real realm. So what should we say? I'm going to say that this function is undefined everywhere, or not defined anywhere. What do you guys think? Undefined everywhere? I kind of like that. It's essentially a fake place where nothing exists. So when you say, what's the domain? There's no domain. It's undefined everywhere. It doesn't exist. It's kind of like the domain would be the empty set. All right, guys, I feel like this is a good place to stop the video. In fact, I might leave the video as it is for tonight and then just talk about, you know what? I'm going to stop talking. Thanks for watching this video. Keep tuned for more on function composition and domain.